Fifth element? No? Okay. All right, guys. So you guys have done some graphing before. I'm going to attack it like we haven't. If I said graph x equal 2, and we've done this several times this semester, we graph fractions and decimals and shit. I just want you to plot x equals 2, graph x equals 2. What would you put on here, for example?
0, yeah. 1, 2.
And what would you put on the 2?
Circle.
I like it. Point. I like it. Cool. So, to be honest, that picture is not very helpful, really. It's kind of helpful if the answer is some ugly fraction and gives me an idea of in between what two numbers is it. The visual would make sense. But I know 2. So where this really comes in handy, now watch. How many letters are in this equation? 1. So how many axes do I have? This is called a number line. It's also called an axis. It's not an axis of evil, necessarily. Too old of a reference? Bush? No? Yes. So this is 1 letter, 1 axis. So if x changes, I'm going to move left and right. How are we doing so far? Some of you guys know where I'm going with this. So the minute I have an equation, now graph becomes really important. Graphing becomes crazy important when I have an equation with 2 variables in it. So if I have something like x plus y equals 5. What the shit? Right. So the one idea I want to throw at you is the fact that this is going to require 2 axes. On top of our normal x-axis, we're going to plot a y-axis. So we're going to say x already controls the left and right. I would never say that. It sounds like Twilight Zone. We control the vertical. What is that? Outer limits. The x-axis controls left and right. We're going to put the y-axis is going to control up and down. So it is truly very much like latitude and longitude on the surface of the Earth. Now the Earth is weird because it's curvy. We're going to use a flat plane, thank God, not a curvy ass thing, right? But latitude and longitude on the Earth. Same idea how to find a point in space, really, is what we're trying to do. How to find a point on this plane. So here, can somebody give me an answer to this? Now think about what an answer is going to take. It's a number plus another number is 5. So any answer is going to have how many parts to it? 2 parts. I like it. So can somebody give me one answer?
2 plus 3.
All right, so here's how we collect that answer together. 2 plus 3 makes 5. So what we've decided to do to organize this answer, because it's got 2 freaking parts, is in alphabetical order, we're going to list them. What I mean is x, y. So if you say 2, 3, that means x is 2, y is 3. I like it. Can you imagine now somebody else give me another answer? 1, 4. Who?
4, you mean?
Who? 4 and
8.
4 plus 8 is...
Oh, wait, you're going in order.
I'm not going in any order. You can give me any answer. Here, let me do an answer. I'll do an answer. I'll take a turn. 20, negative 15. There. You're all in. I wouldn't have said that shit. But is it true?
That's 1 plus 4.
Is it true?
Yeah.
20 plus negative 15 is 5. So, how long would this list be if I kept going and you got all the answers? It would be infinitely long, right? If I had to get them all, I'd have to do it. My kids would have to do it. Their kids, their kids, their kids, their kids. Holy shit. To the end of the earth, and the humans are all dead. And the last person like, ugh. All right, so screw that. There's got to be a better way. I really want you to understand this. There's got to be a better way to represent all the answers to this in a compact kind of way, concise way. This would take forever to do. You guys understand? Do you guys see that? Because not only is it 2, 3, 3, 2, 1, 4, 20, it's also 1.8, 3.2, right? And then the square root of 7, 5 minus square root of 7. I mean, holy shit, it's every number you could imagine as long as they add up to be 5. It's an answer to this. Okay, maybe. All right. So, the way we do this, and we're going to build up to this. I want this to be the motivation. And this somehow applies to this. I want a nice way to give all the answers. It's going to be a visual way to give all the answers to this, because this way sucks. I can't do it. Okay, so the way we do this, let's build up to it. First off, we have to figure out how to graph points in 2D. All right, we're going to step up one dimension. So this is one dimensional. Now we're going to go to two-dimensional. Right? So we have this. Here's our normal number line. This is the X number line, the X-axis. And this is now going to be the Y-axis. I like it. Stay with me now. So this, like always, this could be 1, 2, 3, -1, -2, -3, like normal. So how do you think we decided to do this one? Probably the positive ones up here, I like it. And the negative ones down there. So it's just a number line that's been turned. Right? Latitude, longitude, if you want to think of it that way. So, what's this point right here?
0.
And actually it's the point 0, 0. It's where both X and Y are 0. So we call that point the origin. Okay. It's just the name of it. And you'll see why in a minute, why we call it the origin. So if I wanted to plot the point...
Wait, the origin is the middle.
The origin is the middle. I love it. So 0, 0. So that really means how much have I moved? Not at all. Because the way this is going to work, so if I want to plot the point 2, 3. I want to plot the point 2, 3. We'll call this point A, just so we have something to label it with.
2x, 3y.
I like it. So again, it's alphabetical order. X first, Y second. X controls what direction?
Left and right.
Left and right, like always. Y is now the new direction up and down. Right, we've given ourselves one more dimension to live in. Just to blow your mind away for a second. So this shouldn't blow your mind too much right now, but I'm going to add a little extra. So 2, 1, 2, and then 3, 1, 2, 3. So that's not the blow your mind part. Thanks, though. Is everybody decent with that? Do you guys see that?
Yeah.
It's like saying go 2 blocks east and 3 blocks north. In some city like Salt Lake City. Has anybody ever been to Salt Lake City? Oh my God. It's just so grid-like. It almost, your brain goes, I can't be here for that long because this is just so grid-like. I come from Virginia Beach where streets ran into themselves. And
Yeah,
it's like,
me too.
yeah. You know what I'm talking about? Spaghetti. All right. So that's the point 2, 3. So we'll call that A. So where would be the point? I'll blow your mind here in a second. Well, let me make sure you guys get the basic idea. -3, -1. What does that mean?
Go over -3 and then down.
Yeah. So the first number is the X. So I'm going to go back 3, down 1. I love it. So we're right on the poor little 3 leg. All right, not too bad, right? Most of you guys should have done stuff like this before, but this is how it works. Now, how many dimensions can we experience? Do we know of that we can see? How many dimensions do we live in? 3. I like it. And so I don't know if you guys know that we actually maybe live in 11 dimensions. Let's not do that. Holy shit! We have 3 dimensions I can see, right? I have 1, 2, 3. 3 dimensions I can see. Okay, maybe. All right. So if I could have a point, there would be one more axis. We're not going to do this. I don't know why I'm telling you. I just want to share this with you, because this is the real world. The real world is I got something right here. It's in 3 dimensions. I have to be able to tell somebody where it is. So what if I said it's 2 over, 3 up, and then 12 out? Do you guys start to see? Do you understand? It's not that big of a step from this. 2 over, 3 up, and then either how much up or how much in, right? That would be the third dimension. Then I can tell you any point in this classroom. Right, that point would be maybe 10 down, 1 up, and then 20 over, 20 up here this way, right? Do you guys?
Yeah. Even diagonally?
Well, there's no diagonal movement with the X, Y, Z. Because if it's here, I just move over, up, and then out. If it's there, I move over, down, and then out, right? I mean, I don't have to move diagonally, thank God. Okay, let me stop that. I'm sorry. I apologize. I just want to show you.
For a third dimension then?
Yes, they do. They have what's called isometric graph paper.
Oh, okay.
Where it's sort of like, somebody ever drawn a cube? You know, you draw
Yeah.
a cube, and you can do like that if you want to cheat, or you can do like that.
The lines up, yeah.
It's basically graph paper that's got a bunch of these on it. It's all connected together. All right, let me rein. I'm sorry, this is my fault. Let me rein this back in. All right, because we just started talking about 2, and you went to 3 dimensions. Stop it. That's what flatten it. Okay. So help me out. Take a second. I don't know if you've made this yet for yourself. Graph this. Don't say anything out loud. Graph that point. All right. So this tells me to go where? And now you see why we call this the origin, because where do I always start when I'm about to plot a point? I start freaking here. Right? That's the origin. So then I move over 3,
Go
down 2, bam.
And you put a C right there.
Yep, I like it. So how many pieces does this cut? Of course, this makes 4. So we call these quadrants, which makes quadrants. And for some reason we decided that's quadrant 1, and we decided to go counterclockwise just to be that way. That's quadrant 2, that's quadrant 3, that's quadrant 4. There's 4 of them. We're going to obviously call them 1, 2, 3, 4. It's just which way we were going to do it. They decided to do it this way. Way back when. Okay. How are we doing so far? That's just taking the idea of a number line to the next dimension up, which we see in real life on the surface of the Earth, the latitude, longitude. You also have what's called right ascension and declination if you talk about finding something in the sky. So there's actually a grid you can put on the sky to find things. Okay. So what point, so can somebody tell me what point is this? Yeah, good. I like it. That's the point 2, 0, because it tells me to go 2 over and then 0 up or down. So I stay on the x-axis. So what point is this? No, negative 3, 0 would be there.
0, negative.
Yeah, how much do I move left or right?
0.
None. And then I move down 3. So none left and right, down 3. So if it's on the y-axis, it's going to have a 0 first. Do you guys see that? If it's on the x-axis, it's got to have a 0 second because it didn't go up or down at all. I like it. God, I can't. At least you aren't. Everybody's looking this way. That's good. I can't. Other than that, I have no idea. Okay. So how does this apply to what we were talking about earlier? So one section of homework is just the basic skill of plotting points and then reading off points. So there's going to be part of that in the homework. Yes, sir?
You don't line them up?
Say again?
You don't line them up?
These points that I made just came out of nowhere.
Sometimes there's a part where you do line them up.
Totally. We're going to do that right now. So if the points come from a relationship where the x and y are related, then they have to have some kind of a shape to them. And the first type of shape we talk about are straight lines. So if I have like what we had before, x plus y equals 5, right? What were some of the answers came up with? 2, 3, 1, 4, right?
0, 5.
Sure, 0, 5. I like it. All right, that's better. take a minute, make a XY coordinate plane. Oh shit, that's what this is called. This is the XY coordinate plane. It's also called Cartesian Plane, after Rene Descartes. He's the one that came up with it. Supposedly he was sick in bed watching a fly crawl across his ceiling, and he decided a way to figure out where the fly was. So he had a high fever. This is where this came from. Right? So take a minute, try to plot those points and see if you can see something about them.
What did you tell us to do?
Mark those points.
By the way, if you are anywhere near as messy as I am, maybe even messier,
Is that a 0 and a 5 dot? Yeah, I don't have to.
you're going to want to invest in graph paper, or just go to Google, go to images, type in graph paper, and then print it out, right? Something. You're going to want to do. If I had me in this class, I would say, don't you turn in any of this homework without graph paper. Because I am not the best drawer.
So on this, if you wanted to line it up.
I don't want you to line it up. They should naturally line up.
No, they do.
Yeah. So let's see, 2, 3, 2, 3, 1, 4, 1, 4, 0, 5, 0, 5. I like it. What if I said 4? What would this be? To be true in this equation, that would have to be 1, 4, 1. So they are, if I make them big, because my sucky scale, they are lining up. They have to. I really want this to make sense. If those points just come out of nowhere, like those did, they don't have to have any pattern. They have no relationship with each other. If the points I plot all come from an equation, meaning they all work in that equation, then their graph should have a pattern to it. And if the equation they come from, all the variables have a first power, it's going to be a straight line. If one of them had a second power, it would be what's called a parabola. Right? It would have a curve like this or down, depending on what's negative. Because the minute that one of these is something other than 1, like it's a 2 or 3 or even a fraction or something, it's going to have some kind of curve to it. But it's still going to be some pattern. It's going to be a flowing pattern. It's one leads into the other one, leads into the other one. They're not going to just be all over the damn place. So this, now remember earlier what I said. I can't list all the answers because it's an infinite number. So here's the visual. Here's all the answers. Well, I want the one that's over there. Well, then that's why the arrow's there. You go there and you find it yourself. This is a visualization of the answers to this equation. That's the most basic reason we graph something. It's not even the most important reason, but it is the most basic reason why we graph anything. It's a quick way to answer the question, what are all the answers? There. No, that's not all. Yeah, they are. I put little arrows. Don't forget the arrows, because that means just keep going like this. Right, yes, sir.
Will we ever have to just kind of pick the answers ourselves type thing? Will we get a...
Well, now we're going to move towards kind of making this a little more formalized, because this equation was pretty simple.
Yeah, because
right?
we could pick anything. I mean,
well, yeah, it's pretty easy to tell what adds up to be 5, but
right.
Not every equation is going to be this easy.
Oh, okay. Well, what I was saying was because I could pick 1 out of 4, or I could pick,
I really want this to make sense.
20.
It doesn't matter. Negative 15 and 20 is still going to be on
That's right.
the line.
Yeah.
That's
No,
the
for
point.
sure. Okay, so it wouldn't. So if we had like an equation like that, it wouldn't matter.
It doesn't matter which points you pick. Just to be nice to yourself, you pick
Pick it
points
as
you
close
can
as
graph
you can.
easy. Yeah.
Okay.
Don't pick negative 100 and 105. Oh my God. Why did I do this?
That's
Yeah.
right.
I like it. I like it. Blah, blah, blah. Blah, 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 blah. Blah, blah, blah. Good Lord. So all of a section 11.1, the first big chunk of it is just going to be graphing points, stuff like that. And then they get into this. Now here's the formal way we do this. Here's the formal way we do this. Say y equals. Now this is a little bit more complicated of an equation, but maybe you can see how to do this. For example, if I said, I want x to be 7, can you figure out what y would have to be? -2. So that's basically the way we do this. We let one letter be what we call the input. We input a number, and then we step back and see what number comes out for the other one. So in this case, see how x is going to be the input because y is already solved. So for example, so we make what's called an xy table. So for example, if I make x 1, y would be what? Y would be 4 times 1 minus 3.
Wait, why would x be 1?
Because I want it to be. Why was x 1 here? Because that was a possibility, wasn't it? What could x be? Anything. Now, can y be anything it wants to be if I have an x already? No, it's got to be the y that makes it come out to be 5 in this case. I really want... So x can be anything. But then y has to be the thing that makes it 5. Or y can be anything, but then x has to be the thing that makes it 5. So here, x can be anything. But then y better be what this is. Because it's got to be true. Okay, so I can't just start making anything for x and y. That's crazy. And then the graph will be just all over, but it had nothing to do with this equation at all. So if x is 1, y would be 4 times 1 minus 3, which is what?
1.
Yeah, 4 minus 3, 1. So what point do I have so far? 1, 1. Sweet. What if y is 2? What if x is 2? Y would be 4 times 2 minus 3. You guys see what's happening? Yeah, 8 minus 3, 5. So that's why we did that thing earlier about plugging values in and then evaluating the expression. That's all we're doing now. We're giving ourselves a value for x. We're plugging it in and then we're evaluating it. So what if y, let's see, what if x is 0? Y would be 4 times 0 minus 3. -3. 0 minus 3, -3. So what points do we have? We have 1, 1, 2, 5, 0, -3. Now you guys graph that. Graph those points. And then connect the dots. We know this is a straight line. Why? What do I know this is a straight line? The variables have a first power. Nobody's squared, nobody's cubed, nobody's anything freaky. Oh, cool. So then 1, 1. You almost can't go wrong with 1, 1. That's awesome. 2, 5. So 2, 5. And then 0, negative 3. Yeah, don't go left and right at all. Only down 3. And then, oh boy, make that big, make it big. So then you just keep going, you can find whatever answer you want. Okay, cool, I like it. What you're going to do in Math 90 is talk about, if I had a line like this, it's going up slower, so it's got less slope. So then you're going to talk about aspects of the lines, like slope, some other stuff, special points. This point's special because it's where it hits the y-axis. We call it the y-intercept. So here's what I want you to do. We basically covered everything you need to know in Chapter 11, believe it or not. On the reverse from the practice final. On the other side is some practice problems. I want you guys to try those out. Oh, you need everything. Sure. Yeah, sure. There's that. So we're going to do, that's the practice final. That's what we're going to do right now. Cool. Oh, yeah, they're here. Chapter 9 is extra credit. Chapter 11 you got to do.
I already did mine.
Oh, yeah, cool. You got so much credit.